Hello, everyone. It's a pleasure to welcome you to this important moment in the journey of the Eclipse IDE and its ecosystem. I'm sure that many of you, like me, love the Eclipse IDE and its ecosystem, providing a stable, flexible platform and the power of open source collaboration. Today, I truly believe that it marks the beginning of a new chapter. Actually, it reflects the great progress we have made, thanks to the dedication of the Eclipse IDE working group, and above all, the 200 regular contributors who deliver a stable new release every quarter with over 118 million lines of code. This session is today is designed to be interactive, as I said, so with opportunities for you to share your input, and that's why we will be using Zoom polls during the presentation. Your participation is key to making this discussion meaningful and impactful. And for those watching this session later on replay, be sure to check the video description. You will have a link to a feedback form, and your insights are also very important to us, and we will review all of them with great attention. So just a quick overview on the agenda for today. So we will hear about the working group vision on Initiative 31. It will be presented by your working group chair, Goodchild. Next, Heiko Klare, as coordinator and tech lead of the initiative project, will take us through the findings from Initiative 31. Basically, he will be sharing the key highlights and insights from his session that he did at EclipseCon. And by the way, it was one of the most attended sessions of the conference. And finally, and actually during all the presentation, we will move into an interactive discussion. The goal being to focus on the next steps together, trying to identify contributors who can help turn this vision into a reality. So, Mark, the floor is yours.
Sure. So I'll just share my screen. I've got a very short slot and a short slide to show. So I was wondering how to approach this and how to explain. Sorry, I'm just getting over a cold, so if I'm a bit blocked up, I do apologise. So I wanted to think about how to explain why the working group companies think that the Initiative 31 is important and crucial to the future. So I thought, well, the best thing to do is to describe it from my point of view, from Renesas' point of view. So why is it important? So Renesas are a semiconductor company, and our customers use our Eclipse-based product as their main tool. It's quite an old tool, so it's maybe in Eclipse terms not old, but it is old. So about 15 years of investment. We've added lots of stuff to it. So it's not just an IDE and debugger. There's loads of other features like code configuration and generation and so on. Anyway, the point is there's a lot of investment, and we support we support Windows, Linux, macOS versions of the tool. In addition to that, I'll just get rid of that. In addition, our tool is really dependent on the Eclipse platform and SWT technology. So this investment is all dependent on that. And maintaining the SWT API is also really important. So these are the base requirements of where we are with our tool today. On top of that, we've noticed a few things. So recently, there's been some, shall we say, unusual bugs in the SWT ports. In particular, this one I mentioned, which was about macOS, the splash screen being upside down. So from our point of view, it's clear, I think, on certain OS ports of SWT, the contributions are slowing down. Everybody that's working on SWT are doing a great job, but there is a lot to do and not many people doing it anymore. It's also complicated and time-consuming for platform developers to support all the OS platforms. So there's multiple ports to maintain, and we feel there's risks to our mid to long-term future. So, for example, for Linux supporting GTK4. from a Renesas point of view, it's also really hard to find good SWT developers. So doing it ourselves isn't really an option. In parallel to that, we've got requirements to update our products look and feel in line with competition, such as VS Code and so on. And we also have a requirement to improve the performance of the user interface. And yes, we have a whole bunch of plugins that are heavily dependent on SWT and the Eclipse platform. So from a working group company point of view, we really hope Initiative 31 might be the answer to address some of these problems. And that's why we're interested in it. And that's why the Eclipse IDE working group think that this is a great initiative to tackle this and ensure a better future long term. That's all I wanted to say, really. So yeah, thanks for the chance to share. That's all I have.
Thank you. Heiko?
Yeah, thank you. So, okay, I think we somehow lost you, Thomas, right? I think you're connected with a different device now, but I will just take over because I would like to start now this call with giving you all another overview of this initiative. So I think that many of you have attended the EclipseCon presentation that Thomas has already mentioned on the Initiative 31. Still, there might be some of you that have not seen this presentation or need to have some recap on that. So I will give a shortened version of that talk just to have you all on the same level of knowledge to know what we're talking about, to then start into the discussion afterwards regarding how to proceed with this initiative. So let me share my screen for that. Okay, so I hope that you now see the screen sharing.
Yeah, it's okay.
Perfect. All right, so as I said, I want to give you this overview on the initiative. So Mark already has given an overview on his perspective coming from Renesas. So as you can see, I'm from Vector Informatik. We also have products based on Eclipse. In particular, one large-scale product my department is working on. And so we have, of course, some interest in having an up-to-date platform that we can base on. And that's also one of my tasks in our department to make contributions to this platform. Keep it alive, and that's also where and why we started this initiative to kind of modernize this platform. And what that means, I will also give you an overview about in a minute. So as Thomas already said, we would like to get some feedback, to get some input from you and know what background you have, first of all. So before coming into a presentation part, I would like to first make a poll and ask you which of the following best fits your role. So what is your role in the context of Eclipse? So are you rather a developer making developments or contributing to Eclipse? Are you rather a manager? So would be interesting to know. And I hope that Thomas now can start the poll.
Just starting.
Yeah, thank you.
Hopefully it works. So we will take something like 1 minute on. We'll see how many people answer. Oh, yeah, it's very quick. Thank you for your answer. I see already 40 participants. Do you see? Yeah, you don't see the results on your side. I think we are ready to go. I have 45 answers, so looks good. 46, 10 seconds. Okay. I'll stop it right there. I will share the result with you. Should be visible for you right now.
Yeah.
Good.
Okay. Thank you for selecting. So I see that we have many technical people in here. Many of you are using Eclipse. Even a third of you are actively contributing to Eclipse. So that's great to know that you're kind of involved already into the Eclipse development. So follow-up question, and then we really start into the first presentation part is, so we would like to know what your interest is in this initiative. So why are you here? Why are you interested in this initiative? yeah, you see the options that we found here. We hope that some of them fit for you properly. So are you interested in the efforts? Are you interested in the roadmap and so on? So have a look at the answers. And again, Thomas, I would like to ask you to start the poll.
Done. It's good. I see. I see. People answering very quickly. Thank you. Already 40 people answering. Let's wait 10 additional seconds just to give a chance for slower connection. Okay, looks good. And the result.
Okay, so we see a distributed picture. So you have many interests in this. So in particular, you seem to be interested in the technical aspects and roadmap. I think we have at least parts of that covered in the topics that we have today. You want to give feedback, we will have plenty of room for that in a few minutes. So good. Thank you for sharing that. Then I would like to first go into giving you an overview of what the idea is behind this Initiative 31. So why are we doing this, and what is the plan that we're having behind this initiative? Mark has already given very good insights in why this initiative is so important for Renesas, and I think that applies to many of the companies involved right now. I would like to go to a more, let's say, abstract level, not on the company level, but saying what are the technical or requirements aspect that we have regarding why we make this initiative. So first thing is that it's about the look and feel part. So if we take a look at current Eclipse applications, in particular, if you take a look at those applications running on Windows, they look, let's say, a bit outdated. On Windows, that's particularly because a pretty old API is used, which makes the applications rather look like 20-year-old applications. So we have a comparison picture here between a 20-year-old application and the current one. Of course, there is some modernization because some of the widgets have been modernized by Microsoft. But in general, you see that things look pretty similar. You have limitations in what you can do with this. So you will usually not have the feeling that you have a modern Windows application here, but rather a more outdated one. So that's feedback that we have from many sides, that these applications do not look, let's say, modern. Another part that Mark has also mentioned is the maintenance part. So we have these 3 implementations of SWT for each of the 3 major operating systems for Windows, Mac OS, and Linux, each of them having different versions. For example, we have still Windows 8, 10, 11, and so on with different updates for each of the versions. We have different Mac OS and Linux versions that we all have to support with different issues, and everything has to be adapted there. So there's also many code just for specific of these versions to work around problems that we had with these versions. So this is really high effort to maintain. We always have to make the maintenance in the moment a new release comes from an operating system to adapt to what has changed there. This has become really complicated, in particular, like Mark also said, because not so many people are working or do want to work on SWT right now. That's why the maintenance is, yeah, rather a problem right now. And third point is the customization part. So if you want to customize your applications, make them look like you want them to look, this is, on the one side, it is to some degree limited what you can do right now to customize these applications. On the other hand, this is something that is also driven by the operating systems. So the operating system defines how your customization options look like. In this example here, we see both screenshots on a macOS system, and we see that macOS has changed its default behavior. between the left and the right side of the screenshot, where the vertical spacing between these three items has been changed. And the question that we have to ask here is, why should we even let the operating systems prescribe how the UI looks like and when appearance changes? Because we usually want to make the applications look like we want them to look like for our specific products or for the Eclipse IDE as one of the flagship products that we have. So based on that, if we take a look at other cross-platform applications today, here at the example of the Eclipse IDE, which is also an IDE, a web-based IDE under the Eclipse Foundation. If we take a look at how it looks on macOS, this is the screenshot that you see here, and compare it to the Windows one, you see that things look pretty similar. The only difference is in the integration of the window itself. So the menu bar here is different on Windows, but in general, you usually now have uniform application-specific look and feel, no matter on which operating system you're running. This is also driven by the trend to have web-based applications, of course, and that's what you usually want to have today to make it look the same on all operating systems. Do you also see this red line across the slide here? Or is it only on my screen?
Yeah,
We do,
yeah.
Does anyone of you know how to remove that one? Because I did not introduce it. I saw some different cursor in there.
Maybe Control Z. I think you drew it by accident.
I drew it. No. Oh, it's gone. Okay, thank you. So what do we want to do? Yeah, given these limitations that we see, what do we want to do to improve these things? So when we started this initiative and discussed that we need some modernization here, we discussed what goals we have behind this. And of course, there are many factors that influence what we're doing, but the three most driving factors are the look and feel in general. So I've shown you that it looks, let's say, outdated. The look and feel is perceived as outdated by many people. So we want to have a kind of modernization in there. It's also about the maintenance, which we want to lower by reducing the maintenance effort to reduce the risk and to be sure that we can, with the amount of people that we have to work on this, to really keep the thing alive and to keep the technology. And as a third thing, it's the configurability. I've shown that on the previous slide that we want to improve the configurability so that you can really adapt your applications to whatever you want to look them like on your operating system and on your environment that you want to run it on. But of course, it's not only about the goals that we want to achieve, but also about the constraints that we have to consider. Because when we first started these discussions, of course, you can think of complete replacements of the UI stack and so on, but you need to consider that we have limited resources, that we want to make limited adaptations, and that's why we have some constraints that we consider in this initiative. The first and I think most important one is that we want to keep the effort for adopters low. So concretely, the API should be as stable as possible so that the clients, everyone having an application based on this, should have as low effort as possible to adapt to whatever changes we make. Then, of course, the technology should be cheap in terms of costs, in terms of licensing, maintenance, and so on. And one very important aspect is the part of capacities and skill sets. So we have to keep in mind that we have limited resources, that we have people with specific skill sets that we can put on this project. So let's say if we had a technology which requires 50 C++ developers to realize that, it would of course not be a fitting technology stack because we do not have that many and not that skilled people for doing that. Then when we took a look at the approaches that we can make, we have taken a look at different levels where we can make this replacement with aligned with different amounts of work that need to be done for making this replacement. If we start at the bottom level, we could keep the current OS specific implementation that we have right now, of course. Yeah, that's what we do all the time, that we still develop what we have, these OS specific implementations, maintain them and keep them alive. At the other end of the spectrum, we could say we make a complete replacement with a modern UI stack. Let's say we take a web-based stack like many other applications are doing right now to modernize things. But this would be a very invasive replacement. We would have to adapt all of our clients, all of our products that we have to use these new APIs. And that's why we took a look at the levels that we have in between. So to see what options we have to make it easier for existing products to adapt to whatever changes we make. Starting from the bottom, we could say we just improve the existing OS-specific implementation. So for example, on Windows, we could move to a more modern UI framework that is provided in the Windows operating system to somehow modernize this look and feel, in particular of Windows applications. On Linux, we have to do that anyway, moving from GTK 3 to GTK 4. But if we now consider that we have a new implementation of SWT anyway, so moving to WinUI would mean that we have to re-implement large parts, we can also think about directly moving to something that is agnostic of the operating system. Because today we have technologies that already do this abstraction from the operating system specific parts. So why not directly use a framework that does this work for us? The benefit here is that we still have this as a modernization approach. So we would have another SWT implementation using the same APIs. So all your products could base on the same APIs that than they do right now. While if we move to, in particular, web-based stack, which have a completely different behavior, we would have a migration approach where we need to adapt all of our products. So that's basically the distinction between these topmost levels. And down here, we see that if we stick to OS-specific implementations, of course, we still have to maintain 3 of them, while having an OS-agnostic one would relieve us from the efforts of maintaining 3 implementations by only having 1 of them. So this is the different levels of technologies we could consider. And as you probably know, we have decided to focus on replacing the existing implementations with an OS-agnostic one because we see best reduction of maintenance in there, but still see great possibilities for improving the look and feel and the configurability. As an example here, so when we started the work, we took a look at some of the technologies that may be out there, and we found that GTK is the framework that is used on Linux right now for the UI of SWT-based products. And for GTK, there are also ports available for Windows and for macOS. And there even was an implementation some years ago using the GTK port for running Eclipse on Windows. And we revived that one and found that it was pretty easy to get things running. So what you see here is on the right side, an ordinary Windows-based application. So an Eclipse IDE product based on the Win32 API. And on the left side, you see one based on GTK. But also running on Windows. So in this case, not the Windows 32 API is used, but GTK or the port of GTK on Windows is used. And when we saw that it's so easy to get things running on GTK, we thought that it might be feasible to also investigate other technologies and really follow this path of finding an OS-agnostic implementation that we can use for SWT. What was then also interesting is that, of course, the Eclipse IDE is a cross-platform product anyway. We use it on Windows, macOS, and so on. And we at Vector have a product that is Windows only. So we only develop it for the Windows platform. So we thought that it might be problematic to migrate that one to GTK because we thought that there are possibly many dependencies on Windows-specific functionality. And I tried that out and found that it was pretty easy to even get that application running on GTK, even though it was Windows-specific before. Of course, not everything is working, but it was quite easy to get at least what we see here running. So the basic product with diagrams and so on working on GTK pretty well without making major adaptations to our code base. Of course, keep in mind that all these screenshots do not show you a better look and feel. It's just using GTK right now, which you can also use on Linux right now. It's just to show the feasibility that we can move to one framework that is the same for all operating systems, which then gives us the ability to use all the customizing support that we have for that technology. So when we saw this and saw that it's possible with GTK, we started this initiative with a goal to find out whether it's really possible to use any of the existing technologies to make an OS-agnostic implementation of SWT. So it is called Initiative 31. For those of you asking why it is called Initiative 31, because we're moving from, or the final goal would be to move from the current 3 implementations of SWT to one OS-agnostic one. So that's just the single driver behind this name. And what is pretty important to know or to understand what we did so far in this work is the purpose so far was that we wanted to assess which technology best fits for an OS-agnostic implementation of SWT. So we did not aim to make this implementation to productively use it, but just to evaluate whether we have a technology to do that. So what we did so far is prototyping work. That's where we stand right now. What we're presenting you right now is prototyping work that we have done to identify whether we can do that. So for this prototyping work, we did a technology selection. I do not go into the details right now, but be sure that we've taken a look at many technologies out there, or we try to take a look, of course, at all of the existing technologies. For this, we had some criteria that we investigated. We have some mandatory criteria, like we want to be able to fully implement the existing SWT API, of course, with all the specifics for the different operating systems that we have. We need to have browser integration because that's essential for the Eclipse IDE and for many Eclipse-based products right now. And regarding quality aspects, we of course need proper licensing. We want to have a mature framework because we all have products that will base for several years on this technology stack. So we want to have something really mature, really adopted to rely on this for years. On the optional side, we consider things like the support for executing something in the browser. So for example, if we could execute it via WebAssembly, that could be interesting for web deployment of applications, not as a standard use case, but as an option to make quick deployment, quick testing of applications, for example. And then we first did a paper-based pre-selection of technologies where we had general exclusion criteria, like taking a look at whether these frameworks are cross-platform at all, whether they are properly licensed, and so on. And then we had a list of many, many frameworks, of which we excluded most of them. And finally came up with 3 technologies that we took a deeper look into. So the first of these technologies, as you can might expect, is GTK. I've shown you that for GTK a port exists for Windows. There's also one for macOS. So we took a look at GTK. An implementation for that exists because the SWT implementation for Linux is based on GTK right now. The ports exist. We can make customizing via CSS. And the GTK4 implementation, so some update on the GTK implementation is required anyway. So that's why we took a look at that one. We thought that it might be a low-hanging fruit because there is this implementation existing that we could reuse for Windows and macOS. As a second technology, we took a look at Swing. I will not go into the details because by now we dropped this technology. So if you want to have more information about that, you can look at the EclipseCon presentation that we made once it's available on YouTube. But the other technology that we're still investigating is based on Skia. So for those of you who do not know, Skia is a graphics engine. So just a rendering engine for drawing text, drawing primitives like rectangles, lines, and so on. So there are no widgets in Skia already. So that's why we took a look at widget frameworks based on Skia, but also took a look at custom rendering widgets. So what we try to do there is to custom draw widgets based on just rectangles, text, and so on, but using a very well-developed and performant rendering engine like Skia. So the good thing here is that we have a modern rendering engine underneath. So Skia is, I think, already 20 years old, used for many browsers like Chrome and so on. So that's really widely adopted and a really good rendering engine. We also gain platform independence because we only need to have Skia running on the platform where you want to run your application on. And also from a skill set perspective, it's pretty good because all the widgets can be completely implemented in Java. So that makes it really easy to implement them for people that are usually skilled in Java anyway when working with Eclipse and SWT. And you, of course, gain full control and flexibility because you can do everything you want in the code that you write for the widgets. And that also makes you very independent from any dependency that you have, because a rendering engine is a rather lean dependency that you will have because you just need something that is capable of rendering text and rectangles and so on, but not a fully fledged widget framework, which might evolve and that you have to adapt to then. So to give you a quick overview of what we achieved so far, as I said, it was not the goal to make a full implementation of a technology, but of course we investigated the specific aspects for which we expected to be problematic with that technology. So we started with GTK. And as you've seen before, it was pretty easy to get Eclipse applications running on GTK on Windows. I can also show that to you quickly in a live scenario. So I have an IDE here with the SWT fragment made for GTK on Windows. And if I start an application out of that, you will see that just on Windows, a GTK-based application, an Eclipse IDE application starts. That looks almost the same as the one on Windows, but with the specific properties of GTK that you might know. So you can see here this GTK-based application now. You see that things are slightly different. So you see that the margins of icons here is larger than in the original application. You have different spacings and so on. That's usual properties that you have in GTK-based applications. So everything you see here is rendered via GTK, but still running on Windows. So also here you see that, for example, these combo boxes and so on have more space than you're used to when using a Windows-based application. And what's also great is that you can, as I said before, regarding customizing, you can use the native theming that is provided by GTK. So GTK has a native theming support where you can provide different themes that you can also use for your Linux distributions. And this is something that you can now also apply to just your Eclipse-based application, no matter which operating system you're running on. So in this case, I've applied not only the dark theme that you can use in Eclipse anyway, but a theme that is really different by all the colors here. And if you, for example, go to the preferences, you see that you have different checkboxes and so on, which is all done by CSS styling of GTK. So that's the level of customization that you can apply then. All right, so I've shown you the native theming part. You can also run applications already on GTK4, but they are still rather broken because GTK4 support is not fully implemented right now. That should also be an outcome when we follow this path to have a full GTK4-based implementation of SWT. And on macOS, it was at least possible to get GTK4 snippets already running. So we focused most of the work on Windows by now, but we see that it also works on macOS in principle. Then regarding the Skia stack, we focused on custom rendering widgets, as I said, and it was pretty easy to get first widgets running. So in particular, button, text, and label are the widget that we custom implemented. So in particular, everything that you can see, all the rendering, how it looks like, we implemented pretty fast. And you can experience this in the SWT control example. So maybe some of you know this SWT control example. Let me just start the original one here so that you know what I'm talking about. It is, moment. So it is this application that you see here where you have all the widgets coming from your operating system, all the basic widgets in there, in particular the button. That's what we will take a look at now. You can try out how buttons work, different styles of them, and so on. So this is just the ordinary Windows one that you can see here. And we can now also start that one based on Skia. And you can see that things look pretty similar. So one difference that you can see here is that the rectangles here do not have rounded edges because that's currently an API that is not implemented in the bindings for Skia. But everything that you can see here is custom implemented. So all these widgets that you see in this UI here are custom rendered. So we have written code that renders these rectangles, renders the proper colors, the text, and so on. And it looks pretty much the same than it did before. And in particular, you can now define on your own how it should look like. So for example, how these radio buttons here look like is just custom implemented. You can make them look whatever way you want. Because it's just code written that renders these things. And what's also great with this approach of custom rendering widgets is that you can simply replace one or two of the widgets and see how it works, because you can keep everything else rendered by the operating system at the same time. So I just started an Eclipse application here. So this is just a usual Eclipse application, now also using Skia for those widgets for which we've implemented it. So if you, for example, open the new Java project wizard, you see a page here that is completely rendered by Skia. So all the widgets here are Skia rendered, except for, I think on this page, there's nothing rendered by anything else. But if you go to another page, so for example, these these previews here are still the native ones, but all the other widgets are now custom rendered, and it perfectly fits into each other. You can make things work together based on the custom parts and the native parts until you have replaced everything with a custom implementation if you want to. So, Thomas, do you want to say something?
I was just wondering if you want to answer a question. We see we have some question coming in the chat. So you want to address them later on? You want to, as you want.
I would just finish this part of the presentation, then I will have a look into the question, and maybe you can just have a first look into the questions and then present them to me so that I do not have to read all the chat afterwards. I'll just finish this one. So I've shown that in live demo, so I do not need to go over the screenshots here as well. One interesting aspect here is that we can now also exchange the graphics rendering engine underneath. So what I've shown you is that we render these custom widgets based on Skia, but you can also do it with the rendering engine that you have from your operating system. So you can also let them render by the Windows engine that you have anyway. And one interesting point that we found is when we made some performance tests using text rendering. So there are some performance tests in SWT right now which do some extensive text rendering. And when using proper graphics acceleration with Skia, we found that it takes less than 40% of the execution time than we have for the native rendering support that we currently have with Windows. So it would be basically a speed up of 2.5 for the rendering performance of texts based on Skia here. All right, so do we have any technology-specific questions that we should answer right now coming from the chat?
We start some of them. Already got some answers from the room. I think the first question was
Okay.
Yeah, the first one was if did you I'm going back to the history. Yeah.
So I think that many of them have already been answered in the chat, right?
Yeah. Is it supported and concerned GTK4 performance scalability?
Okay. So
no.
Then maybe
Okay,
I can just proceed first. So I'm almost done with my part. We also have some questions prepared for you so that we can then move to more discussion after that. So just to give you an overview where we stand right now, what we want to discuss right now is so the project started at the beginning of this year where we generated the idea and built this first prototype that you have seen. Then in May, we started over with making the actual prototyping work now that we did with 4 companies that you see here, where we started the evaluation of all the criteria that we found interesting. And at this point, again, I have to thank all the people that were involved and did all the work. So all the screenshots, all the live demos that you've seen is work done by all these companies that were involved here. And we extended the prototyping to, let's say, the end of this year to find out which of these technologies to put focus on. We have this interested party call today, and we would like to soon decide which way to go. So whether we put more focus on the GTK or on the Skia technology, because both have arguments for and against them. Everything I've shown you is publicly available. So I think also in the invitation to this call, you found the links to the GitHub organization where we have all the information, all the documents that you can take a look at, and where you can also try out all this code. Now, coming to the future, coming to the actions and why we are here, we would now like to know, so we have some questions, as we said before, prepared for you. First thing that we would like to know of you is whether you would really like to see what we've shown here, which is just prototyping work with some first results, transform into really productive implementation of SWT. So whether you say, well, it is interesting for me to have such a new technology, or whether I'm fine with whatever we have right now.
Okay, we have basically everybody, 52 answers among the 60 live participants, so I think it's good.
So we already have answers in the chat. Depending on the technology, we will have a question on that just following. So we see that many of you are interested in having such an implementation. So 75% have some interest in that. So I would like to, so before coming to the question regarding the actual technologies that we want to focus on, what are the next steps so that we know that you know how we want to proceed. So from a, let's say, organizational perspective, we will start proper projects out of this. So with regards to GTK, we can do all the work in the existing implementation, of course, in the existing SWT repository. For the Skia prototype, we would like to move to an Eclipse incubation project where we provide this these prototypes and develop these prototypes in an ordinary process under the Eclipse Foundation. Regarding the prototyping work for GTK, I saw some question regarding performance in the chat. If I'm not mistaken, that's what we're currently investigating. So clarifying the performance of these ports compared to the existing implementations, compared to the native GTK one on Linux. With regards to Skia, we are fully implementing some widgets right now to see how much effort it is, because that's the thing we know least of, and to implement the style text as one of the most complicated widgets, and also to integrate graphics engine hardware accelerated rendering via OpenGL. What is pretty important is that we can also have increments that are useful. So we do not have to have a full implementation, but we can also make increments that are useful. For example, on GTK, it's having a GTK 4-based implementation. And on the Skia side, we see that we can also use this for making performance critical parts more efficient. So for example, rendering diagrams can be very more efficient when using an efficient engine like Skia. So just to, that you know that it's not necessary that we complete this work, but that we can also have benefits when just making increments with this work. So what we would like to know of you now is that you've seen these technologies, which of them you would prefer. So which of them do you find most interesting, in particular when you consider that you would like to base your products for the next, let's say, 5 or 10 years onto these technologies?
All is started.
Okay, and while you're answering, I can just answer the question regarding why IBM use native look and feel in the first place. It was simply because 20 years ago, there were no such OS agnostic framework that had the performance, that had the native integration and so on that we have right now. So of course, 20 years ago, you had Swing, but it was not a technology that you wanted to use 20 years ago. So having a native look and feel back then was something that you that had some benefits in terms of the quality that it had, in terms of the performance that it had. So that's why I think it really made sense to have this decision 20 years ago, but it's not a decision that you would make today. Okay, so we see a preference for Skia, also some interest in GTK, and some of you even would like to see Swing, but it's such a minority that I would say it's probably good to not put further focus on this technology. So one thing I would like to stress now is, and that's also why we are here, is that we would, of course, like to invite you to join this initiative, because we now have the choice to either accept the current state and keep SWT as it is, or to find a path for modernization together and share efforts in doing that, because that's what we also do all the time when using Eclipse technology. We work together on this technology to all benefit from what we do together. And we should also do that with respect to this modernization efforts of SWT. It's really important to stress that the work that we have done so far is something which is only prototyping work, and we had the resources for doing that. But to make a full implementation, a productive implementation out of this is something that we can only do as a community effort. And this is nothing that will happen without all of you being involved and putting efforts into it. But also note that when you start contributing, you can actively influence where we go. Yeah, you can decide which technology to use. We can decide, or you can decide on which properties to put the focus. So that's really beneficial when doing these contributions to this initiative. And considering if you would like to contribute, or if you are contributing to this initiative, then which technology would you really like to work on? So not which technology you would like to see realized by anyone, but which of them would you actually like to work on yourself? Okay, and there was, so meanwhile, there was the question in the chat about why Swing is not considered an option anymore. So yeah, that's a good question. So first of all, Swing is kind of frozen version support, right? So it's not developed further. You can still use it. It's shipped via the JDK, but there is no evolvement in that. And so if we found any limitations that we have to work around or that we would need to overcome when using Swing for implementing SWT based on top of it, it's not clear whether that would be feasible to make that possible, to integrate that in the JDK to make these improvements to Java in general. And also we are, of course, if you have some technology that is not adopted anymore, that is just under frozen version support where no one is using it anymore for a new project, the question is whether that's really the choice for something that you want to rely on for 5 or 10 years. Of course, we see in the chat that it's still used by IntelliJ, but yes, new products are not based on Swing anymore for different reasons. And so we definitely have to ask ourselves whether that's the best technology to base on. And taking a look at the question that we've asked before, we only had 6% of the people interested in that. And it's really a problem if you do not trust in a technology, if you do not want to use it, then the question is, even if it's technically a good choice, if no one wants to invest into it, then you cannot really proceed with that technology. So I think we have a pretty similar picture to what we've seen before.
Yeah. Pretty
so
similar with a little bit less people answering. Maybe because some of the people don't consider working on it, but it's still many people answering the question. Thank you.
Okay. Good. Then final question that we have to you is, as I said before, we really depend on you to contribute to this project. So what would be your way of contributing to these efforts of modernizing SWT? So would you be able to make active contributions? Would you make financial contributions, or any other way in which you can contribute to making this real? And meanwhile, I see the question regarding the learning curve regarding Skia. I think we also have the people that worked on Skia here in the call, so maybe they can also answer on that. But my impression was that the learning curve is so you're really fast in getting first results with Skia, because you have to know that the API of Skia is pretty simple. You have an API that looks like the graphics context that you have in SWT right now. So you can do things like drawing rectangles, drawing text, and so on. So that's really easy to use. Most of the complexity will be in the code that you write for custom drawing the widgets. So to render the widgets, to make the event handling, and so on. But using Skia itself is very easy, and you can just try it out with the prototype that we've provided on the GitHub organization, where you can just check out the code. There is a README in there how you can do that, and then also make simple changes to the widgets if you want. So make the buttons look a little different, and you will see that it is pretty simple to start working on that.
Yeah.
One more thing that I want to add is we already have used the native GC of the widgets. That means it's possible on the one hand side to draw the widgets with the native GC, and it's possible to use Skia, because Skia, that what we've implemented is Skia also implements the GC to some extent. And that means it doesn't matter whether you draw the widgets with the native GC or with Skia. in the end, we actually plan that you do not really know which graphics content, which drawing engine you're really using. It's more like you're using a GC, and with that you can draw the widgets. And I hope that makes it quite easy for the widget drawings.
Thank you.
It's done. I share the result right now.
Mhm. Okay, so I think we had multi-selection here, right? Yeah, that's in there. So it's
I hope it was clear. It was possible to select multiple.
Okay.
Also. Yeah.
But great to see that so many of you are not only interested in seeing what happens, but also on making contributions. So in particular, writing code, that's of course what we can expect if most of you are rather technical people and not the people doing decisions in your companies. But yeah, really great to see that you would like to work on this, make contributions. So first of all, thank you for that. And we will take the last few minutes of the presentation to also give you some information on how you can contribute, where you can contribute. But now, so we've answered some of the questions on the fly. If you have any further questions, please speak up now. And meanwhile, I will try to take a look at the chat to see which questions were in there that we might need to answer.
Heiko, my question would be about event management.
Mm-hmm.
And how do you fire all the events, how manage propagation and all that stuff if you use Skia? Because drawing, from my previous experience, is the easier part than that.
Yeah. Dennis, maybe can you say something on that? So you worked on focus handling and so on. So can you give some impressions on that one?
Currently, we are on a hybrid mode. That means a lot of events will be fired still from the underlying window manager, from the underlying widget toolkit. But the more we develop this, I think we will create more and more events by ourselves. For example, if someone uses tab, then at the end we have to take care of the focusing by ourselves and the next tabbing, next focusing. That means we will have to create the events by ourselves and fire them. It's also the same with the selection. Currently with the selection, we just execute a notify on the selection, and by that, it actually works quite well.
Yeah, so we still currently have the event queue of the operating system at hand, right? So we can also pass events to that queue that will be different once we replace everything. So to be completely OS independent, then things will of course change again.
You have a hand raised.
Yeah.
Yeah. You can speak.
Okay. Hello.
Yeah.
Hello.
I want to ask about the language support. Sometimes I have some problems with Persian and Arabic language and right to left.
Mm-hmm.
And I want to say, is it okay to use some other language and some Arabic or Persian or languages? Is it okay and better to the last version of the?
So you mean to use other languages then in your applications in the UI?
Yeah, yes.
Okay, so first of all, that should of course be the goal that it's supported. I think we have not taken too much a look into that right now. So for GTK, it will be the same than it is right now. So if you're using that on Linux and it works there, it will work the same. For Skia, we will have to look at the same as well. But my expectation would be that it's not so much a problem because Skia is also right now used, for example, in web browsers. So underneath Chrome and Firefox and so on, the same engine is used. So I would expect that this will not be a problem because we have language support there as well.
I know that from the Unicode side, the fonts definitely support Chinese signs and I think also Arabic signs. I'm not that sure about the right to left feature because I have not yet seen it, but that doesn't mean that it doesn't exist.
Vlad, you have a question? Thank you. Majid. Vlad?
Sorry, I was on mute on my headset. Thank you for the presentation. I have a question about Swing, or even more precisely about AWT. So you said that you do not consider Swing for rendering, but did you consider Swing for the events, for isolating from operating system? In this regard, because, for example, there is a thing called Compose Desktop by JetBrains, I believe. They do it, and they use Skia for rendering, but since they don't want to spend a lot of effort on integration with all the event loop and stuff, they basically use AWT for this. So all the keyboard, mouse, drag and drop goes through AWT. It is pretty, I mean, yes, it is not developed, but it's also not going anywhere.
Okay, so that's an interesting interesting approach. We have not considered that yet, but definitely something we can take a look into. So thank you for that feedback.
Actually,
I would.
Can I add one more thing to that?
I would say, actually, since we're running out of time, I would like to make the closing right now. So to give you all the information, how we can proceed. If any one of you wants to ask questions afterwards, can still ask me anyway. But just to let you know how you can now contribute, how you can get involved. So let me see. So I think I hope you know why you should contribute. Yeah, we want to have a migration instead of a modernization instead of a migration approach. So to make it easy for all of you to move to something more modern without much effort, to make more progress, to have better configurability, cross-platform, uniform look and feel, and so on, and also to reduce your cost and your risk regarding maintenance by focusing on a single technology. Now, you've seen all of us, you've seen Thomas and Mark in the initial presentation. So if you take a look at the presentation afterwards, you find our contact data in here. So in particular, for those of you rather decision makers, please contact Thomas. You can also contact me and my manager at Vector, Johannes, who is also here in this call and is also a member of the steering committee and in the board of directors at the Eclipse Foundation. So just reach out to us if you want to. And now, the channels where you can contribute is, of course, by just joining the efforts. We have a weekly meeting every Friday, so it will be tomorrow at 1 p.m. Central European time. You find the link here to the Zoom meeting where you can just join. And we also have some chat channels, so the Matrix channel and the Slack channel. Choose whatever you want, whatever you feel more comfortable with to just get in contact with us. And yeah, so first starting point would be to join our call tomorrow if you're interested, and then we can talk about how we want to proceed on a technical side.
Thank you, Heiko. And since everything is recorded, all these links will be made available in the description of the video on YouTube. And anyway, we will communicate. As you said, we have many places where you can join and contribute to the project. So, and feel free, first of all, maybe the easiest way is to contact us and reach out to us. So thank you very much, Heiko. We are perfectly on time, so I think we can close the meeting, but we're really looking forward to seeing you and to seeing this project doing progress. And so, see you later. Thank you very much.
Thanks, Heiko.
Thank you.
Thanks, Thomas. Thanks, everyone.